Good morning, everyone. Welcome to Concept Class. Today, we'll explore the first two stages of the AI project cycle: problem scoping and data acquisition. Before solving any problem using AI, we must first understand what the problem really is and what kind of data we need to solve it. Problem scoping is like setting a direction for your project. If you don't know where you're going, any road will take you there. So, the first step is to deeply understand the problem, define the goal, and identify all the factors that affect it. To scope a problem clearly, we ask the four W's: who, what, where, and why. For example, if we're building an AI solution for school attendance, who, students and teachers; what, irregular attendance; where, at school; why, to improve discipline and academic performance. These questions help us form a complete picture before jumping into data or coding. Let's take a simple example. If we want to solve food wastage in our canteen, we first identify who is involved, what the issue is, where it happens, and why it's important. This structured thinking helps in defining a meaningful AI project. After asking the four W's, we write a problem statement. It's a clear summary that defines what your project aims to achieve. Remember, a good problem statement is specific, measurable, achievable, relevant, and time bound, also known as the SMART rule. Every problem has factors that influence it, both internal and external. For instance, in weather forecasting, data accuracy and sensor quality are major factors. Understanding these helps us design better and more realistic solutions. Once the problem is defined, the next step is to collect data. In AI, data is like food. Without it, the model can't survive. So we focus on collecting the right kind of data from reliable sources. Data comes in many forms. Some is structured, like spreadsheets and tables. Others are unstructured, like images, text, or social media posts. Understanding the type of data helps us decide how to collect, clean, and use it effectively. In AI, we often use the term features. They're like clues that help the model understand patterns. If you're predicting house prices, the area, or the number of bedrooms are important features. Data can be gathered directly through experiments and observations, or from secondary sources like reports and public datasets. But it's crucial to ensure that data is accurate, complete, and up to date. Remember, wrong data means wrong conclusions. When we build an AI model, we don't use all data for training. We keep a portion aside to test whether the model really learned the pattern. This process is called splitting data into training and testing sets. System maps show how the parts of an AI system interact. For example, in a weather system, sensors collect data, the model processes it, and the output predicts tomorrow's weather. It's like a map of the entire AI journey. While gathering data, reliability is key. Avoid random internet data, prefer government websites, research repositories, or platforms like Kaggle. These sources provide clean, well-labeled datasets. Kaggle is one of the most popular platforms for AI learners. You can download datasets, learn coding techniques, and even participate in global challenges. It's a great place to practice everything we learn in class. The quality of your data decides the quality of your AI. If the data is wrong or irrelevant, the output will be meaningless. We call this the rule of garbage in, garbage out. So always filter and validate your data carefully. To summarize, we first identify the problem clearly. Then we gather the right data to solve it. This foundation determines the success of any AI project.